In a previous video, we designed and tested the 3D printable Anik Wanda filter up there, and it is working better than I expected. Unfortunately, there's still one really big problem to deal with. It is not fully self-cleaning. It's pretty close. For this to be a success, we need it to be 100% self-cleaning. The goal was to take all of the debris that could possibly end up on our roof. That includes bugs, that includes sticks and leaves, pine cones, pine needles, all of that type of stuff, and be able to filter it out so we get relatively clean water that ends up in our rain barrels. And then we can use that water to water the plants in our garden. We're really close, but still really far away. So in this video, we're going to use some 3D printable solutions, and we're also going to integrate this into the filter as well. So stick around. So the first thing that I want to deal with is the duct tape. That is no good. And the reason for that duct tape is just as a precaution to make sure that these could never come apart, because I found those tiny stones were attracted to the magnets that I have in here. And there's a risk that they could fall apart from each other, especially if there's a lot of water coming down. And all of that water, of course, has some weight to it. It could have pulled the pieces apart. So we need to come up with a new system, a proven system that works, and there's one right above us, this right here. This clamp ring actually works incredibly well, and it works on these barrels for an airtight seal. So why can't we come up with something like this that is 3D printable that we can use on that system there? So my first solution is these. These are clamp rings, but they're made from TPU. They're somewhat flexible. The pink one or salmon one is quite flexible, and this one's a bit more stiff. The yellow one is from TPU 95A High Flow. And the salmon one or pink is 90A. So this would be great for like a gasket material. It's stretchy, but after making these, I didn't really get the feeling that I'd be able to apply that force and control that to get the surfaces to meet tight together and create a really good seal. So I decided to go in a little bit different direction, and I created these. These are PETG high flow clamp rings. So you just need to separate it a little bit. You can open it up, and there you go. And the really good thing about this is that you have complete flexibility on the rotation of these parts. So one thing we need to do with this clamp ring is install a heat set insert. Because this is flexible, we can do this and put our heat set inserts in there. I made the adjustment to the adapter. So this will go to my downspout, and I will make sure that I have this size available, which is the 3x3, but also have a 2x3 available. And then my plan is, if everything goes well with this testing, that I will also make some other adapter sizes so that anybody with basically any setup can use a system like this at their home. So this goes on here. We can just, again, expand the collar. I plan on putting a gasket in between here to act as a seal. I am able to load in that extremely flexible filament, and to do that, what I have to do is take this top tube, disconnect it from the AMS setup, and run that tube through that hole in the back and bypasses that. And that allows me to connect that really soft TPU on the side of the machine and run it more directly to that hot end. So you can see there's a little bit of movement, but I don't think that's going to be much of a problem. Yeah, perfect. So these clamps are actually the second version. I have hollowed it out just a little bit more in this area, and that way only the bottom and this top section are actually the ones that are making contact, and that way that causes it to want to pull together as we tighten this screw up. Really good. So the next thing that we need is a piece of acrylic. It is going to be sandwiched in between these two pieces. This is also a new version. This is PETG High Flow. Luckily, I do have a piece of acrylic. This is actually from Maker World. We need something that's 100 millimeters in overall length. If you don't happen to have a table saw to do the cuts, you could probably get away with a miter saw, but you'd have to be really careful. I would recommend using just a hand saw, or a hack saw would probably work as well. You can smooth the edge with a hand file afterward. What I also did was I made some changes in here. You can see that I have a recessed area, and that mimics the pipe as well. So it has a defined stopping point in there, but you can see it's far too big for the pipe. Now this is 1.25" PVC pipe. It's schedule 40. So what I originally did was I printed this TPU gasket, and this is that high flow TPU. It's a little bit too stiff, but it does fit in there well and does work. It's just a little bit too stiff to get that pipe all the way in. So I printed this salmon colored one instead. It's much more flexible. And that one can go in there with the thick end towards the back. Fit that in. And now the pipe can go in there. And the deeper that pipe goes in, the tighter the seal gets. There we go, it's bottomed out all the way. The final version is actually going to have a slight change on the bottom. You can see that I have this recessed area and a tapered section as well. That's so that it was more easily 3D printable. I wanted to see what it's going to look like with the debris that is shed off. And to do that, we're going to use some more acrylic. So I have this piece of acrylic. This is the full length. I think it's 220 millimeters, same size as the other one, 100 millimeter in diameter, 94 on the inside. And I printed this PETG high flow ring. That fits onto here. And that fits on there, and that will be glued in place. And now we'll be able to see anything that comes through. We'll be able to at least get a little bit of a shot of what is going past. And on the bottom, you can see we have the exact same detail for that clamp ring to grab onto. So I'm going to go ahead and glue anything together that does not have a TPU seal in it. So this will work exactly as it is, but we still want to make one more little change to that, and that is to try and add this inside of there. Because this is all closed in, it's really difficult to see what's going on. So I've made a flat version that's open on this side, and we can see what's going on the back side. I want to run some water over here. We'll see how much we actually capture, which would be off of the back, and how much is actually left, or it's going to go down the downpipe and not be captured. When I originally designed the Anaconda filter, I thought it would be okay to lose a little bit of water down the downpipe, and the reason for that is because I thought we'd have enough rain to easily fill up the barrels. But after experiencing some of the summer rains, or rather summer storms, they may only last for 4 minutes or 10 minutes. So it's actually much more important to capture as much of that water as possible during that time. And when the barrels end up filling up, it then acts as an overflow and the water can then go down that downpipe. So then the question is, how effective is this filter actually? How much water are we gaining? How much water are we losing? So this test filter that I created is actually very similar to this one, other than the fact that it's flattened out. And we've also changed the slats to be positioned horizontally, whereas these ones come up in this coil shape or spiral shape. And the main reason for that is so that this is easily 3D printable. If I were to change it to be horizontal, I would end up with much more straight lines in between here, and we get a segmented effect, and I really wanted to try and avoid that. And we have a beaker on this side, and we can put a beaker on this side. And so we can see what's happening a little bit better, I'm going to add some food coloring to that water as well. And I'm going to guess that we're able to capture 90% of the water maybe. And the captured water is going to be on this side here, the back side, and then on the front, we should see very little water, hopefully. So let's give it a go. All right, so there we have it. I have a bit of a messy setup here. We ended up with a lot more water. In this side here, the captured side versus this, now on the initial pour, it seemed to kind of skim along the surface just a tiny bit, but once it started to flow, then it continued to flow and it was able to capture it. So this is the amount of water that we have that was not captured. And here we have the captured as well. So I think we're probably somewhere around the range of 95 to 98%. And again, it seemed to only skim along the surface on the initial pour. So I found some stainless steel mesh on Amazon. You can see it comes in a roll. And this mesh is non-magnetic. And I think this will work fairly well. It's kind of the idea of the coffee filter. It looks maybe even a little bit finer. So this is a 350 mesh. I will have a link down there below if you'd like to try out a mesh like this yourself as well. And it is an opening size of 0.04 millimeters. You can barely see through it, but you can see through it. So first, let's find out if water will actually get through this mesh. So my main concern now is this mesh too fine? And I think this type of thing is used in a coffee filter, maybe tea filter, those types of things. So it should work. I don't see why it wouldn't. So let's put some water on top. Oh, that's not working at all. Not a single drop is coming through. What is going on? There is something funny going on here. This does not make any sense to me. I'm wondering whether there's some residual oil or something like that from the manufacturing process on this that might be stopping the water from getting through. So what I was thinking was maybe I should clean it off just using a little bit of soap and water and a toothbrush, and we'll just try that same test again. So everything is mounted and I have a lot better feeling about this now. And the reason I went with something that's so fine is because I really wanted an ultra slick surface to be able to shed off some of that debris much more easily. The other thing is I think it's a good idea to filter out some of the fine particles too. At the end of the season, we're not going to have nearly as much of a cleanup job. We're also not going to have those fine particles maybe bunging up the system and the valve. So now we can give this a try. Oh, it is going through. So I think this might actually end up working for us. Now I'd like to try it on this filter as well. So I'll cut a piece. We'll be able to glue it onto here and see what happens. This is just with super glue. That is not the final solution. I have a much better idea for our actual filter, but this will work well for at least this test. So let's go ahead and pour the water on and see what happens. What seems to be happening, and what I was hoping for, is that this mesh is actually distributing the water much better. It's diffusing it, and that's why it ends up spreading out at the bottom there, and it seems to be dripping just beyond that little edge there. So I've glued on just a little bit of mesh there. We'll just give this another try, and let's see what we have. It's still leaking a little bit out the side there. So I've cut our stainless steel mesh into a shape that will fold up or roll up into a cone. So it's got a slight curve on the top, slight curve on the bottom, and it's a little bit longer than it needs to be as well. I'd like to have the connection, I'd like to have it overlap itself on the inside too. So now really we just need to figure a way to get this installed in here. And to do that, what I'd like to do is use these rings. I've printed these internal clamp rings. And these ones here are again printed from that softer TPU. They're a little bit too flexible. I went back to the yellow high flow TPU, and I think these are going to work a little bit better. And I think it's also important not to mess the stainless steel up too much. What I mean by that is to kink it. So I just need to get the bottom one in. I actually forgot to wash this, so I'm going to have to unfortunately wash it in here, but you can see how smooth that is. That actually works really well. I think the lower clamp ring I will just expand a little tiny bit more, even 0.5 millimeter, just to provide a little bit more outer pressure, but other than that, it is looking really good. It was raining a little bit earlier. It is still spitting right now, and you can see just getting a little trickle coming through, but it was raining a little bit harder earlier. So So this is where we're at right now. The clamp ring worked awesome. I didn't even bother to put the screw in there. Whoa, the door just slammed on me. Okay. Put something behind that. There we go. All right. And we're starting to get a couple drips coming in there already. So there's a little reservoir on the bottom that is bigger than the original one. Also gonna get the pipe installed down on the bottom too. Oh, nice. Beautiful. All right, so it is raining a little bit heavier, and you can see it is working. One thing I noticed though is that we're actually losing a bit of water. You can see it's actually dripping on the inside. It's not hugging against the wall. So I think the culprit is that I modified these on the inside there. It's not as gradual of a slope. So it's kicking off of the bottom of the pipe, coming in just slightly, and then staying in the center there until it gets near the bottom. So we are losing a little bit of water. That's important water to collect, especially if the rain is really, really light. And in order to do that, I'm going to be printing a new adapter here. It's going to have a little change on the inside. Aside from that, this thing is working great. Let's see how clean this water is. The water's a little bit more brown than I was expecting it to be, but the water is very clear and there's only a couple little fine particles, and they may have come from the previous filter as well that were stuck in the pipe. Okay, so that's what it looks like. Some drips coming through the center. And a few drips out the bottom. This is the before. I was in a bit of a hurry, so I printed this new one with a 0.8 millimeter nozzle. So let's get this off and get it installed. And you can see there's a bit of a difference in there. My hope is that the water that was otherwise dripping out will catch on this edge here and then hug the wall, hug the side all the way around. So hopefully that will do the trick. Ho ho ho, that is looking really good. Squeaky clean. Beautiful. Okay. And you can see the new version is pretty good, but it looks like some of the water is actually hitting the top lip on the inside there. I'm going to make another little tweak there just to have it a bit more gradual on the very top, and that should pretty much solve that problem of splashing water. Okay, I think I'm ready to put all of this back through. These are all the stones that we had a lot of trouble with in that filter. And also the Samaras. We're going to put some pine needles through there as well. And just a bunch of random things and see how that new filter design performs. All right, we'll let that settle, but you can see a ton of stones have gone down there, and hopefully the rest are in there. I think there's probably going to be a few more little fine particles that have gotten in, but nothing like it was before. Just very, very fine particles getting through that mesh. That's okay. And for the final test, I have a mixture here of pine needles. I have Samaras, I have grass as well. Grass gave me some trouble the last time. It was just getting stuck into the filter. I also have some leaves, and I also have some sticks, and I have some remnants of the pine cones. The squirrels have been going crazy eating the pine cones, spruce cones. So they look like they could get stuck in just about anything. They're really, really thin. Okay, the moment of truth. Let's have a look inside the filter. See what it looks like. And let's see what we've got. Oh, pretty good. Pretty good. There's a couple little stones that are just kind of hanging on there, but I don't see them being a problem with a bit more water to just wash away. The same for these. So unfortunately, when the water kind of dries up, it's just going to leave that little bit stuck there. When they dry out, they can fall off on their own, or when enough rain comes down, it should wash them away. But overall, I'm very happy with how this is performed. That's all of that stuff that we sent through there, all of those stones, all those pine needles and everything that could have clogged it up. And maybe we'll do a quick spray test to see how easy this comes off. Oh, look at that. Look at that. Washed it right down. So that is going to work perfectly. This thing is actually self-cleaning. So once a season, maybe I'm going to take this mesh off. We'll see how it goes. We have to test this over the long term as well. Also, experimenting with different mesh sizes is probably a good idea. I wonder if I went a little bit finer, whether I could do even better or whether there's even a point to doing that. So I think we finally solved the issue of self-cleaning. And the great thing about this mesh going on the inside is if you've already printed one of these from the previous design, you can simply line your existing one with the stainless steel mesh of your choice, and then I have this template, and I'll put a link down there below for the template you can print off yourself. We've also solved the problem of the magnets attracting these small stones and causing that little problem, and at the same time we have a much better seal for that connection between the separate parts. And now we also have the ability to rotate this whichever angle we want to make it work for our particular setup. So the final version will look basically like this one. It's going to have the clamp ring section up on the top. It's going to have the clamp ring section on the bottom. We're going to have the new adapters. I'm going to have 2 sizes for now, but I'm planning on adding more adapter sizes as well. And hopefully that is going to work for basically everybody in every single case. So if you're enjoying this type of content and you want to help support this channel, please give the video a thumbs up, and any comments you can add down there below for your suggestions for improvements to this design are very much appreciated as well. Thanks to my patrons for helping to support this channel and making videos like this possible. Thank you for watching. Take care, and I hope to see you on the next one. So I decided to go in a little. And in the last design, we only had 7. When I originally designed this, So first, I think we're going to need to see if the water is actually going to be able to penetrate. So first, let's find out if water will actually get through this mesh, and that will that'll have that clamp ring so that we can attach the downs. So the final version that I'm going to link down below will look basically like this one, except it's going to have a section on the top for the clamp ring, and it'll also have one on the bottom as well. And that way we can attach whatever adapter works for our particular setup.